Hi, Charles Fader here with Hanby Environmental. Today what we're going to do is run some soil tests. What we're going to do is we're going to use a contaminant, PCB contaminant. We're going to do two different tests, one with Aroclor 1016 and one with Aroclor 1248. These are PCB contaminants. These PCBs are in these standards that we purchased here from ResTech, which has the contaminant, the PCB contaminant Aroclor 1016 and 1248 at a concentration level of 500 ppm in transformer oil. So we're going to contaminate our soil with transformer oil with PCB Aroclor 1016 and 1248 at the 500 ppm concentration level. And what we're going to do in the test that we're running is we're going to be using ELMN8, this hydrocarbon cleanup oxidation, a chemical oxidation product, to treat that contamination and see the difference in the knockdown or the breakdown of both contaminants, the transformer oil as well with the PCB in it. So let's go ahead and get started. So the first thing we're going to do is we've got our soil samples here. There's 25 grams in each one of these beakers here that I got from outside. And the first thing we're going to do is we're going to use this jar here to have it as our mixing chamber, if you will. And so we're going to go ahead and put our first 25 grams in there. And put that in there. And then our second 25 grams of soil here. And now we've got that in there. So now we've got 50 grams of soil here. And the first thing we're going to do is we're going to start putting in our contaminant here. This is Aroclor 1016 in transformer oil at a concentration level of 500 milligrams per kilogram or 500 parts per million. So we're going to go ahead and open that up. Okay, let's use this here spoon to help us get into this. Stickers here, they got this thing packed up pretty well. There we go. Got to break this tape seal to get into this contaminant. There we go. So we can get our first one out here. There are one mil containers here, and we're going to use 3 of them. 3 of these 1 mil of transformer oil with the Aroclor 1016 contaminant in there. We're going to use that for our contamination. There and there. And then now this one. So, there we go. All right. Now we've got our contaminant ready to go. So what we're going to do is we're going to contaminate this soil, this 50 grams of soil that we have here, with the contaminant, make it nice and homogeneous, and then we're going to take out 15 grams and put it in this jar here, which is going to be pre-treatment. And then after we've done that, we're also going to take out 5 grams and do it with the Hanby method, just typical soil Hanby methods. Measure out your 5 grams of soil, use your extract solvent, stir it around to pull out the contaminant. Pour it in the test tube, add your white catalyst powder, cap, shake, develop the color to see what we get as the starting concentration pre-treatment. Then we're going to treat it with the ELMN8 product here we got in this jar here, and in doing that, we're going to then measure out 15 grams for that jar, and then do our Hanby method with the 5 grams, and then we're going to do that twice. We're going to do it with the 1016 and then over here with the 1248. So let's get started. First thing we're going to do is get our contaminants out here. These are standards in, again, the Aroclor 1016 and transformer oil at 500 ppm. So they've got these measured out here in these flame-sealed ampules, so we got to break them. There we go. So our first contaminant going in here. hydrocarbon oil doesn't want to come out as easily as a lot of contaminants would. But I think we've got the bulk of it out there. Okay, we're going to use 3 of them, so. All right. So there's number 1. Come in here with number 2. One. So we've got our contaminant in our soil now. So we got some contamination. All right. So now what we need to do is stir up our soil sample and make sure we get that good mixture up in there. Get that soil up against the walls there and get make sure we get all that contamination throughout that soil sample. Okay, we got that soil sample very well mixed up here, so I think we got our transformer oil with our Aroclor spike PCB contaminant in this soil sample nicely now. So at this point we can now measure out our soil samples. So let's go ahead and get our scale out, turn it on, put our beaker on, hit the tare button, and measure out our 15 grams that we're going to send to the laboratory for analysis, for confirmation analysis of what we're doing. Let's mix it up again and get some from a different part. Just make sure we got a good homogeneous representative sample here from what's in this jar. They need a minimum of 15 grams. So after there we are at 15. I mean, at this point it really doesn't matter for their side, but they just need a minimum of 15 grams. So after we do the Hanby where we take out our 5 grams per usage, we'll put the rest of it back in there. We're at 15.1 grams here. Again, it's not gonna matter, we're gonna add to it anyway. So it's a 15.07. So we've got this side, this is gonna be our pre-treatment that we're gonna be sending to the laboratory. Okay. So we've got that measured out. That's going to be our starting concentration level. Now, let's measure out our 5 grams for our Hanby method. get some from a different part of the sample in here and make sure that we got a good homogeneous representation of what we're doing here. We're lower. We're at 5.33, so let's back some off. Get some to, that's 4.6. 4.8, 4.9, 4.96, 4.97, 4.99, 5.0. Okay, there we go. So now let's go ahead and cap this jar while we do our Hanby method for the starting concentration level. Okay, so traditional Hanby method. Now that we got our soil sample, our 5 grams measured out, put in our extract solvent. Now we've trapped those light volatiles from dissipating into the air. We've got that contamination trapped. So stir it around to do our extraction. 10-15 seconds is sufficient. This is not a clay sample, it's a kind of sandy sample, so it's very easy to create that surface contact with this extract solvent with the contaminant and pull it out. So very easily done. Okay, we've done our extraction. Get our test tube marked Aroclor A1016 pre for prior to treatment, and we're going to pour out that extract into the test tube up to the scribed line, which represents 4.2 mils of our 10 mils of extract solvent that we used. And there we go. All right. Now simply add our color development reagent catalyst to it to develop our color and to figure out what our concentration level is. Okay. Notice I haven't even shaken our test up yet, and notice how it's already changed color. So in this case, because the Aroclor is in transformer oil, the color is not matching up perfectly. But whether we compare it to this Aroclor calibration, look, we're way off scale. Look how dark that is. It's way over 500 ppm. That's because we have 500 ppm of the Aroclor in there. But in addition to that, we've got it sitting in transformer oil, so we can go to our transformer calibration, which is here, and we can see that we're way out here. So I would, this is over 10,000 even with the transformer. So we have 500 Aroclor in there, but we're transformer oil that is sitting in is way over 10,000. So we're going to quantify that later by using our mobile application, but in any case, let's just see there. You see that, as well as when it was compared to our Aroclor calibration, that PCB calibration, which was here. Again, way off scale there, so way over. Well, we put in 3 mils of the transformer oil that had 500 ppm of the Aroclor in it. That's why we're way off scale. So there we go. So in our next, we may want to back it off and maybe only use 1 instead of 3 since we're so far off scale. But nevertheless, so we'll leave this at transformer oil now. So now let's go in there and let's treat this contamination with some eliminate. Now, I was going to use 3 mils of contaminant and 3 mils of eliminate, but because we got so far off scale with that much, we're going to probably use a little bit more eliminate and see, because we're really interested in just proving the concept that we can treat this contamination and knock it down. So, so in this case, I'm probably going to use, since that's way off scale with that 3 mils in there, I was going to use, only 3 mils of this, but I'm going to use That's about 2 mils there that I've put in so far. I'm gonna grab another pipette. I'm gonna get a larger pipette. I'm probably gonna put in 10 mils. Just because we're so far off scale, I want to bring that really into range so we can actually see it. So instead of using this 1 mil pipette where I actually didn't get a full 2 mils in there because I didn't bring the level up high enough, we're going to use this here. This is a 10 mil, no, it's a 5 mil, so we're going to have to do it twice. So that's like putting 5 mils in plus the 2 that was in there was 7. Actually, you know what? Yeah, let's go ahead and do it twice. I'd rather overkill it and make sure we get it nice and treated and all out of there instead of under. Okay, so in this first one, what we've done is we put in somewhere between 10 and 11 mils. Well, probably, I guess between 11 and 12 mils actually. So we 10 with the second pipette and, you know, about 1, almost 2 with the first. So let's go ahead and create that surface contact of this eliminate solution with the contaminant that's in there by just doing a shake. In this case, let's put this contaminated spoon over there. We'll use our new spoon now that we're going to separate out our 15 mils to send to the lab, another 5 mils for the Hanby method. This shaking is allowing us to create the surface contact with the eliminate solution, making sure it touches that PCB transformer oil contaminant, because that's what it takes to do the treat. All right, let's let it sit and separate out a little bit. What's going on here? Yeah. Okay, put our scale on, put our empty beaker there, use our clean spoon here, and we're gonna need to measure out 15 grams to put in this, which will be our post-treatment. This is going to be a struggle even to get my 5 grams that I need here. So let's do this. Let's get our 5 grams that we need for the Hanby method out first. And then we can just dump all the rest of it into the jar is needed for the lab. That way we're guaranteed to get our, if they need to dry it out or whatnot, they can do what they need to get there. Because there should be, in fact, what I may do is I may switch the jar now. Okay, so what we're going to do here, we're going to switch the jar. We're going to change the lid so that this now becomes the lab sample. We knew that there was, we used 15 over there, we used 20. We put 50 grams in here to begin with, and we took out 15 for the pre-treatment plus the 5 for the Hanby method. So we took out 20, so there was 30 in here. We took out 5 for the Hanby method here, and that means that there's, sitting in here, there is still 25 grams within this solution. Oops, I'm going to change the jar cap. That's right, because the other one's labeled. You know what? I'm just going to relabel this one because I like the fact that there's also some on the lid that they could maybe somehow get off. So we're just going to change and rename that lid with this lid. But I'm going to leave it in there because I want that that soil that's on the inside of that lid. Aroclor 1016 post. So this is the post treatment that's going to the lab. Those two samples will go to the lab. Okay, so now back to the Hanby method. Ooh, oh geez. Okay, good. We've got our soil sample here for the Hanby method. Grab our extract solvent, put it in. Grab our spoon. Use the other end of it to do the surface contact to pull any contamination that's left in that soil sample out of the soil and into our extract solvent. Okay. All right, now grab our test tube marked A1016 post and pour our extract into the test tube up to the described line. Again, that's represents 4.2 mils of the 10 mils we used as our extract solvent. And add our color development reagent catalyst, our white powder. Wow. Notice, unlike the other one that went completely dark right off the bat, notice how light this is. Now there's a black speck in there. I saw there was some discolored catalyst that was up under the cap that came through as I was transferring it from the little vial, but that's not going to affect our result much at all. So the key here is to notice how white our result is. Comparatively, we started with this super dark color that's way off scale by any stretch of the imagination, and we got this white color post-treatment afterwards. So whether you compare it to the transformer oil way off scale above 10,000, and now you got this super light color. And notice in those specks in there, we really want to look at the overall color. Those specks in there, those black specks, that came through from the transfer from underneath the cap of this particular vial. That it was stored in, which we've see that how there's some brown underneath that vial. That's what transferred over here and created those specks. So that's not actually discoloration from the contaminant. If it was from the contaminant, the entire catalyst would be discolored, like here in the pre-treatment. Notice it's really stark white still, actually. So great reduction here. As you can see, when we compare it to the transformer oil, or if we go back to the calibration for the PCB, which is the Aroclor 1016. Oh, you know what, I was showing y'all wrong earlier. It's down here, this one. Not up, that's 1248 up top down here, so it's 1016 is down here, but notice the reduction there by treatment. So again, this is so far off scale with so much contaminant that on this next treatment, instead of using 3, we're only going to use 1 for the Aroclor 1248 that we're doing next. So very, very good picture here what's happened. All right, moving onward to the next one. Let's grab a paper towel real fast. I got some soil on my scale here. Let's get this cleaned off a little bit. There we go. Okay. All right. On to our next contaminant in our next analysis here, where we're only going to use 1. Again, we're going to start by emptying our 25 grams from this beaker in there, and a second 25 grams to give us 50 grams in there. And now, this time, our contaminant is Aroclor 1248 in transform oil, again at 500 ppm or milligrams per kilogram. So this time though, we're only going to use one of these instead of 3 like we did on that last one, because it made us way too dark. We want to bring it in range. I wasn't quite sure how much contaminant to use given the fact that we were having 50 grams of soil, and so in this case, let's just use one this time. So we're going to use one, not make our concentration so dark. So just one vial here, or 1 ampule of our contaminant. And I'm still going to throw it over here. Go ahead and get this contamination in here. Transformer oil with this small opening doesn't really want to come out all that easy, but ultimately it does in the end. Got it out. Okay, so now let's stir that around nicely to get our contamination into the soil mixture homogeneously, meaning getting it all nice and contaminated evenly, so that the entire soil sample, all 50 grams, have some contaminant in them. And then when we measure out, again, we're going to measure it out by a couple different places to make sure we get a nice representative sample in both our Hanby 5 grams and our lab 15 grams, so we know what our starting concentration level is. And then again, after treatment, we'll do it the same way. Okay, so we've got our soil sample nice and mixed up. We got a good contamination level. So this first thing, let's measure out our 15 grams to put in our pre-treatment jar for the lab. So turn on our scale. Come on, scale, what did I do? Here we go. Put our empty beaker there. Let it weigh the weight of the glass, hit tare, take it out. Let's measure out our 15 grams of soil. This is right out of the middle there. Let's take some from this side over here. Let's take some from this side over here. Let's take some from this side over here. And then let's go over this corner over here and grab some. Okay, that's 15.18. Again, all they need is a minimum of 15, so we're good there. Transfer that over. So they've got their 15 for doing their lab analysis. Okay. Grab the wrong cap. That cap goes there. This cap goes here. There we go. So we got our 15 grams for the pre-treatment. Now let's measure out our 5 grams for Hanby here. Again, we're going to do it the same way. Take some from over here. Take some from over here. Take some from over here. We're at 2.78 at this point. And now we're at 4.45. Let's take some right out of the middle and on the top right here. Okay. Measure out our 5. Oh, there we go. We're at 5.2. Let's just take a tad. There's a little chunk right there just to get us back. We are at, put that chunk back in there, we're at 4.88. Let's get it just a little bit in there and get us closer to 5. 4.93. 5.0. 5.00. Good. Okay, so now let's put the cap back on this, which is our sample. Now we got our Hanby 5 grams out. Let's add our extract solvent to it to do the extraction. Okay, all right, let's stir that around to increase the surface contact of the Hanby extract solvent to extract or pull that hydrocarbon contamination out of that soil sample and into the solvent. By stirring it around, we're increasing the surface contact of the solvent with the contaminant that's in the soil and pulling it out. So there we go. Okay, we got that. Now let's grab our test tube marked A1248 pre, which is our chloral 1248, the PCB contaminant, in transformer oil, which is why the color is so different. But then let's pour off into our test tube here up to the scribed line. Again, we use 10 mils of extract solvent, and when we pour it off to the scribed line represents 4.2 mils. Okay, next step, grab our color development reagent catalyst, this white catalyst here, and pour it in. Yeah, instead of that very purple color we got from that high contamination, at least it started out as yellow and it's a little bit darker yellow now, but at least we know we're not going to get black by only using one as opposed to when we used 3. So our starting concentration level should be a lot lower now. It's darkened up quite a bit since I shook it. So, but not near as dark as that previous one. One function of that is it's a different contaminant. It's a different PCB contaminant, but notice how much lighter it is. So we did a good job. Should be, in this case, again, you know, the Aroclor PCB, and we're talking about 1248, which is this top one here. Again, we're way off scale, and that's a function of our measurement isn't just of the Aroclor, it's a total petroleum hydrocarbon or TPH measurement. And in this Aroclor in our standard is in transformer oil. So a TPH measurement is a combination of both of them. That's why, although we know that we have 500 ppm in our standard of just this particular PCB contaminant, it's so much darker than that 500 ppm because in addition to that we have it sitting in 1 mil of transformer oil. So again, we're way off scale again. So the reality behind this is to really do this, we'd have to, if we're going to use that 1 mil in each one of those vials, we would have to really have more soil to spread it across further. Nevertheless, okay, so we've got our starting concentration measurement again. Now let's go back to our original sample and let's treat this now. You know what? Since we used 1/3 of the contaminant, let's also use 1/3 of the treatment. So we use between 11 and 12 milliliters of the ELMN8 solution to treat that first one, which was such a high concentration. This time, let's just say that we used 12 on that previous one. Even it was somewhere between 11 and 12, but let's say we used 12. So 12, and we used 1/3 of the contaminant this time. So 12 divided by 3 is 4. So let's only use 4 mils of ELMN8 in order to treat this sample here. So this is again a 5 mil. So we're going to stop at 1 mil. So we've got that up to the 0, which represents 5 mils. So let's drop it down to 1, which would represent the fact that we've got 4 mils of ELMN8 solution going in here to treat this sample. Okay. You can see that jar hasn't had a whole lot taken out of it, so you know, it's not as liquidy as like the other one, so we're going to actually have to stir this around very well in order to create that surface contact with that ELMN8 solution to make sure it's treating that contaminant that's in there. Notice as we're stirring it around, we're doing a pretty good job here. We're creating like kind of mud. So our ELMN8 solution is, because we had soil was dry and now we're creating it like mud, so we are doing a good job of creating that surface contact with the contaminant that we need here. So it's doing good. It was enough. We could have added more, made it more soupy or, you know, more muddy like that other one. Notice that thing there. But this will be sufficient. So, okay. So the next step is we're going to run our Hanby, and we're going to leave everything else in here. So we're going to run our Hanby to find out where we're at visually from the Hanby method, the colorimetric method. And then we're going to leave the rest of it in there, and that's going to become our sample going to our laboratory. So in this case, we are just going to switch tops because we didn't shake it in there and get it all dirty yet. So let's measure out our 5 grams for post-treatment in our Hanby method. Measure our 5 grams of this treated. Get some, that was from dead center. Let's get some from over at the side here. Let's get some from over at this side. And I knew I was going to do that. It seemed like it was a little bit much there. We're 1 gram too high. That's 5.27. Let's see if we can get just a tad bit more out of there, and then we'll be closer to 5. That's probably too much, right? Yep. All right, that's 5.1. We're going to leave it like that. Let's put this back in here. Make sure the lab has plenty. All right. We're going to cap that, and that's going to be our post-treatment going to the lab for lab analysis. Now, for our Hanby method here, let's come in here, get our extract solvent, add our extract solvent. And since I got some of it on the side there, let's pour it down the side, make sure we get anything that's in there. Okay, and stir it around. Make sure we increase that surface contact of the solvent with the contaminant that's in the soil and pull it out. Making sure that solvent goes on the side of that jar there where we had some of that soil. Make sure we get anything that's in there. Increase that surface contact with that solvent and make sure we pull it out. Okay, sufficient extraction there. Now we're going to grab our test tube marked again A1248, but post, so meaning post-treatment. And we're going to pour off from that extract, from that 10 mils of extract solvent, we're going to pour off to the scribed line, which represents 4.2 mils. Done. And now the last step in the Hanby process is add your color development reagent, white catalyst powder, cap and shake, compared to the picture. So, here we go. It looks good to me. It's stark white. And there we go, people. Stark white. That means bingo. Again, we were doing Aroclor 1248 in this case, and there's our treatment results from way off scale down to here to 0, non-detect. Look how white that is. That's I mean, look how white it is. At 10, you'd have that, you know, off white color. But look how white our result is. So that's compared to that one. Now let's go to the other one, because our contaminant, our Aroclor 1248 is sitting at 500 ppm in transformer oil, so the larger amount of the contaminant there is transformer oil. Look, we are way off scale over there with that dark color. Now down here 0. So in both sets, again, this is Aroclor 1248 where we only use 1 mil of the contaminant here, which is again 1 mil of transformer oil with Aroclor 1248 PCB in it at 500 ppm. This is our that result, and then our previous one was our Aroclor 1016, the same thing, but we used 3 times as much contaminant, and these are our results here. So the drawback conclusion here is obviously that the ELMN8 works effectively in treating this contamination level. So it doesn't matter if you compare your results to the Aroclors, the PCB calibrations here, which in this case, this is 1248, so it would be up here at top. So this is our last one we just did, and then this is the one we did earlier. But I mean, in both cases, you can see that we went from very, very way off scale, very highly contaminated, to next to nothing, or non-detect in the second one case. Or even if you compare it to the transformer calibration again, same thing. You know, way off scale for our pre-treatment, near zero or zero, near zero with the first one, and zero definitely with the second one there. So the ELMN8 solution is very, very, very effective in treating not only transformer oil, which is our main contaminant, because that's what our spikes are in, is transformer oil, and then also effective in treating the Aroclor contamination, of which the PCB Aroclor contamination, whether it's the 1248 or the 1016, those are stored within the transformer oil. So very, very effective results here in the treatment. So obviously it worked very well. Very pleased with the results that we got here. Boom, bingo. So I'm gonna make those so it's easier to read what they were. Again, the purple looking ones are pre-treatment by the ELMN8 product, and the white ones are post-treatment by the ELMN8 product. So very effective, works excellently. So that sums it up. Conclusion with our experiment here is that, yes, obviously Hanby is very effective in the detection of both Aroclor PCB contamination as well as transformer oil. Likewise, in the cleanup process, the ELMN8 product is very, very effective in the treatment of that contaminated soil as well. So, you know, this is it for now. I'm going to send these off to the lab for analysis, for confirmation sample analysis, but thank you. I'll follow up to the video later with the lab analysis when I get it returned in 10 days.